Our topic for today is about atomic structure and interatomic bonding. Okay, let's start. The property of a material depends on geometrical atomic arrangement or what we call atomic structure. In addition, it also depends on interaction between the atoms. Simulan natin sa atomic structure. We all know na ang atom ay merong small nucleus which is composed of protons and neutrons. And ito ay may orbit, at sa orbit nandun ang mga moving electrons. Both protons and electrons ay may charge. Ang electrons ay negative 1.602 times 10 raised to negative 19 coulomb, and ang proton naman is positive 1.602 times 10 raised to negative 19 coulomb. While yung neutrons are electrically neutral or chargeless. How about sa atomic mass? Masses for the subatomic particle are small. Protons and neutrons have approximately the same mass, which is the 1.67 times 10 raised to negative 27 kg. Which is, mas malaki ito kaysa sa mass ng electron na 9.11 times 10 raised to negative 31. Next is the atomic number. Each element is characterized by the number of protons. Yan ang atomic number. For a complete atom or electrically neutral na atom, number of proton is equal to number of electron. The atomic mass of a specific atom may be expressed as the sum of proton and neutron within the nucleus. Although, may mga pagkakataon na yung number of protons, same yan sa lahat ng elements, pero nagbabago-bago yung number of neutrons. Bakit? Atoms of same elements have same atomic number, but it can differ in atomic mass, which are called isotopes. Ito yung reason why they have same atomic number but different in atomic mass, meaning yung mga neutrons ay iba-iba. For example, yung carbon. Mga isotopes ng carbon is carbon 12, carbon 13, and carbon 14. Their number of protons ay pare-parehas. All are 6 protons. Pero, yung number of neutrons niya ay iba-iba. Sa carbon 12 ay 6, sa carbon 13 ay 7, and carbon 14 ay 8. So, ang atomic mass nila, which is the number of proton plus number of neutron, is 12, 13, and 14. Atomic mass is something we can use to describe an atom. Yung sum ni proton and neutron. Again, carbon 13, carbon 14, these are the isotopes. Same atomic number but different in atomic mass because they differ in number of neutrons. How about yung atomic weight? Atomic weight corresponds to the weighted average of the atomic masses of isotopes. Okay. The atomic mass unit may be used to compute the atomic weight. Yung atomic mass unit na nakuha natin kanina, which are 12 AMU, 13 AMU, 14 AMU, pwede natin itong gamitin to compute the atomic weight. Again, yung composition, let us assume na yung composition na gagawin natin is 80% ng carbon 12, 10% ng carbon 13, and 10% ng carbon 14. We will now determine the atomic weight of our carbon atom. So, tandaan natin, atomic weight is the weighted average. So, kailangan natin kunin yung average ng bawat isotope. So, 80% times 12 AMU plus 10% times 13 AMU plus 10% times 14 AMU, and we will get 12.6 AMU. Again, atomic weight of an atom may vary depending on the isotopes. Pero yung mga common isotopes na nakikita natin sa periodic table, makikita natin yung atomic weight nila sa ibaba ng kanilang element name. Yan. And ang atomic weight may be specified in symbol like AMU per mole, yung unit nila, or yung common na ginagamit natin is gram per mole, where 1 mole is equal to 6.022 times 10 raised to 23 atoms, which are called Avogadro's number. Okay, tapos na tayo sa atomic structure. Punta naman tayo sa mga atomic model. One early growth atomic model was a simplified Bohr model. And sa Bohr model, it states that electrons revolves around the nucleus in fixed orbits. And another principle ng Bohr model stipulates that the energies of electrons are quantized. Meaning, electrons vary energy in each energy level. So, tandaan natin, near the nucleus, low energy level, habang palayo ng palayo sa nucleus, mas tumataas yung energy level ng mga electrons. To summarize, Bohr model represents electrons in atom in terms of electron orbitals and their energy level. Every electron of an atom is characterized by 4 parameters called quantum number. Okay, quantum number dictates that the number of states within each subshell, and our first quantum number is the principal quantum number n, or represents by n. It take integral values beginning with 1. Okay, so sometimes yung principal quantum number, dinedesignate natin siya na K, L, M, N, O, and so on. Ano ba ang principal quantum number? Okay, so it is related to the distance of an electron from the nucleus or its position. So, dinedesignate niya lang kung ano yung distance niya from the nucleus. And the second quantum number signifies subshell. It is denoted by S, P, D, F, and it is related to the shape of the subshell. For shell 1, ang subshells are S, for shell 2, SP, for shell 3, SPD, and for shell 4, SP, D, and F. Third quantum number. The number of energy state is determined by the third quantum number. So, it focuses on energy states of each subshell. For an F subshell, the energy state is single, and for P subshell, the energy state is 3, and for D subshell, the energy state is 5, and for F subshell, the energy state is 7. Ganito natin ini-illustrate ang mga energy state ng kada subshell. Mamaya, malalaman natin kung para saan ba itong mga energy state na ito. And next is the spin moment. Spin moment can be oriented up and down, and spin moment is related to our fourth quantum number. Again, it can be oriented up and down. Every spin is equal to 1 electron on the energy state. So for example, yung S natin, ang number of electrons sa subshell ng S is 2. So we have 2 spin moment. Sa P naman, we have 6 electrons. So we have 6 spin moment. And ganoon din sa D subshell and F subshell. So ano lang yung kailangan nating tandaan sa spin moment? In each subshell, kailangan mapuno mo na yung mga upward motion o upward position ng electrons bago yung downward spin moment ng electron. So katulad nito, for example, yung P subshell. So, uunahin nyo munang punaan yung mga upward spin moment. So, itong isa, dalawa, pangatlo, bago pupunaan niya yung sumunod na mga spin moment na downward. Ganan, nagwo-work ang spin moment sa uh, isang atom. Okay, doon naman tayo sa driving principle para mas maintindihan natin yung mga ito. There are three driving principle of electrons. First is the Pauli's exclusion principle. It states that no two electrons can be identified by the same set of quantum numbers. For example, this wrong one. Dahil hindi sila opposite doon sa isang subshell, so mali yun. Kailangan opposite yung spin. And this one, kung mapapansin natin, yung 1s, opposite ang spin, yung 2s, opposite ang spin. So, every energy state dapat opposite spin. Another principle is the oboe principle. It states that electrons feel the lowest energy level before feeling the higher energy level. So, para mas madali nating maintindihan, dapat mapuno mo na si 1s bago ka mag-proceed kay 2s, bago ka mag-proceed kay 2p, and so on and so forth. Okay. So, kailangan lowest energy papunta kay higher energy level. And our last driving principle is Hund's rule. It states that every orbital in a particular sublevel is initially occupied by the single electron before any orbital is doubly occupied. Such single occupied electrons have the same spin. So sabi ko nga kanina, mauuna muna lahat ng upward spin moment. Yan. Bago mapuno yung downward spin moment. Okay, ganan nagwo-work ang mga driving principle ng atomic model. Okay, let's go to electron configuration. Electron configuration is the structure of an atom that represents the manner in which the states are occupied. Okay, kung mapapansin niyo yung figure at the right side, this is the pattern kung paano gumagawa ng electron configuration. Okay, try natin sa arsenic. Arsenic has 33 atomic number. So, sundan natin yung pattern ng electron configuration. 1s2, dapat yung mabibilang natin na number of electrons will be equal to 33. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and 4p3. Bakit naging 4p3 na? Kasi 2 plus 2, 4, plus 6, 10, plus 2, 12, plus 6, 18, plus 2, 20, plus 10, 30. So, kailangan na lang ng tatlo. So, plus 3, 33. Kaya tatlo. Doon na tayo mag-end ng ating electron configuration. Yan. Okay. Make sure lang na yung sum of electrons in each state, lahat yan will be equal sa atomic number. And to know the valence electron, we need to summarize the number of electron in each subshell. Sa shell 1, 2. Sa shell 2, 2 plus 6 is equal to 8. Sa shell 3, 2 plus 6 plus 10 is equal to 18. And sa shell 4, 2 plus 3 is equal to 5. And yan ang valence electron. Electrons at the last shell. Valence electron is the electron at the outermost shell. These are the most energized electrons. Sabi ko nga kanina, habang palayo ng palayo sa nucleus, mas na-energize yung mga electrons. Kaya at the valence electron, nandun ang mga energized electrons. Okay, let's study periodic table. Periodic table, here elements are classified according to electron configuration. Electrons are arranged with increasing atomic number in horizontal rows called periods. Ito yung mga horizontal rows. Yan. it is called periods. And elements are arrayed in a given column or group with similar valence electron, yan, as well as chemical and physical properties. And yung mga vertical columns na nakikita natin, yan naman ay mga groups. These groups are classified to different properties. Group 1 is alkali metal. Group 2A, alkaline earth metal. Group 3B, 2B are the transition metals. Group 3A to 6A are semi-metals or semiconductors. Group 7A are the halogens, and Group 0 are the noble gases. Furthermore, yan, most of the elements come under metal classification. So, lahat ng nasa metal classification are sometimes referred to as electropositive elements, indicating that they are capable of giving up their electrons to become positively charged ions. So, para mas maintindihan natin tong electropositive elements or the positive ions and the electronegative elements or the negative ions, ibig sabihin lang nito, kapag ikaw ay nag-give up ng electrons, 'di ba sa common o sa neutral na atom, electrons, the number of electrons is equal sa number of protons. Kapag nag-give up ka ng electrons, meaning mas mataas na yung number of protons mo kaysa kay electrons. Kaya ka naging positive ions. Kapag ikaw naman ay nag-accept ng electron, meaning mas mataas na yung number of electrons mo kaysa sa number of protons mo. Kaya ka naging negative ion. Kaya lahat ng nasa metal classification, sila ay may capable na mag-give up ng electrons, kaya they are positive ions. And lahat naman above metal classification are capable of accepting electrons. Dahil nag-accept sila ng electrons, they form negative ions. Okay, let's go sa mga bonding. First bonding na alam natin is ionic bonding. Ionic bonding is the easiest to describe and analyze. It is always found in compounds that are composed of metallic and non-metallic elements. In other words, ionic bonding occurs between positive and negative ions. The attractive bonding force between positive and negative ions are termed as Coulombic force. For example, ng ating ionic bonding, sodium. Sodium is a metal element and chlorine is a non-metallic element. So, sodium is a positive ions and chlorine is a negative ions. So, ang purpose ni sodium is to give up electrons and si chlorine naman is to accept electrons. So, when they are combined, ionic bonding, when they are bound together, they form a sodium chloride. Yan ang ionic bonding. How about sa covalent bonding? It requires sharing of electrons between adjacent atoms. Two atoms that are covalent will contribute at least one electron to bond. Okay. So, pag covalent bonding naman, it is sharing of their electrons. Si hydrogen, kailangan ko ng isa. Si carbon, kailangan ko ng 4. So, dahil si hydrogen, it needs 1, isi-share niya din yung isa niya sa carbon. Kaya, and there are 4 hydrogens dito na nakadikit kay carbon, meaning, naging stable na yung compound dahil kumpleto na yung kanilang element sa orbital. So, ang tawag dyan is they shared their electrons. Kaya nakabuo tayo ng CH4, which is composed of 1 carbon and 4 hydrogen, and CH4 is also called as methane. Okay? Again, covalent bonding is common bond for non-metallic elements. How about metallic bonding? Okay, metallic bonding is found in metals and their alloys. Metallic have 1, 2, or 3 valence electrons dahil they are included in group 1, group 2, and group 3 sa periodic table. With this model, these valence electrons are not bound in any particular atom. So, hindi sila nagbabound sa kahit anong atom. Dahil nga, hindi sila nagbabound, they form a sea of electrons or electron cloud. The remaining non-valence electron form iron cores which possess a net positive charge. So, lahat ng valence electron, para mas maintindihan natin, lahat ng valence electron ng pinag-combine nating elements ay hindi nagbabind together but they form a sea of electrons. At yung mga non-valence electron naman is naging mga ion cores. Ayan. So, tapos na tayo sa ating topic for today. Okay? Thank you for listening and see you next class. Have a blessed day ahead.